Say hello to Sesame Micro. The world's smallest self-propelled quadruped robot dog with 8 degrees of freedom. I spent the last 2 months designing and researching this adorable little robot, just to answer one simple question. How small can you build a robotic dog? This question first arrived when I started building the Sesame Robot Project, a fairly small quadruped robot that I designed and built a little while ago. And while I was researching and designing this little guy, I found myself asking what the limit on size was. So I looked online and saw that many people are designing different versions of robot dogs. But a lot of these are fairly large, so I kept digging. It turns out researchers in laboratories have shrunk this technology down to a micro size. This little thing here is technically a robot dog, and its 4 degrees of freedom are actuated externally. While this work is incredibly cool, it's almost a little bittersweet. I mean, a tiny robot dog should be cute, right? So I came up with an evil master plan. I was gonna make my own robot dog with 8 degrees of freedom at minimum, and it was gonna be self-powered and fully wireless. Starting out, I was actively working on the Sesame Robot Project, which meant I had a lot to base my initial designs off of. Specifically, I knew I wanted to continue to use servo motors. Servo motors are probably the easiest way to get robotic actuation that's trackable and reliable. And I also wrote a bunch of code already that runs on an ESP with servo motors, so it was kind of perfect. Since I had a general idea of what I wanted to do, I went in search for really small motors. You see, the servos I used in Sesame are micro servos, but actually they make them even smaller. These super micro servos are actually called pico servos, and lucky for me, they're usually sold online under the name DMS0020. And while I was pretty sure they were used for super micro planes, I was gonna try and make them work anyway. Another fun discovery I made is that they go the other way in sizes as well. There are jumbo servos that have like 100 kilogram ratings. I'm an American, so I have no idea what that means, but if you want to see a giant Sesame, let me know. Now that I had the motors figured out, I could start designing the frame around them. I used the exact same design strategy I used for the bigger Sesame robot, where I placed the motors an equal distance away from each other by the shafts, then started designing a secure frame around them. As the core of the robot, we need this part to be pretty strong and also securely hold all of the different motors. Then I just started working outwards, designing the legs. The software I'm using here to design all of this is Autodesk Fusion 360, and honestly, it's like the Swiss Army knife of CAD tools. Not only can I design my entire little robot in this software, I can also CNC machine it, 3D print it, basically anything I could think of. And what's crazy is learning how to design in Fusion has unlocked a ton of opportunities for me, and that's why I'm honestly super excited that I get to partner with CAD Class for this video. CAD Class is exactly what it sounds like and so much more. They've got specialized curriculum for Autodesk Fusion 360, and it's truly awesome because you can become a master in Fusion really quickly through this. Regardless of your skill level, CAD Class can help you CAD, and honestly, CAD doesn't really sound like a word anymore, but you get the point. People ask me all the time how to get into robotics and engineering, and honestly, learning something like computer-aided design is a really great start. So of course, a huge thank you to CAD Class for supporting this video, and if you want to learn more, I'll have a link in the description you can click on. Alright, back to designing and building a really small robot. At this point, I've already got a basic design done, and I just need to start prototyping. I've also got a rough schematic in my head of how the electronics are going to work, so let's go ahead and dive in. This part of the process always involves printing, testing, and then making revisions. It's kind of a loop. It's the engineering life cycle. I feel like people always talk about how the journey is better than the destination, but I don't know, it's kind of frustrating when it doesn't work 4 times in a row. Anyway, during prototyping, I always use a cheap filament that I have lying around because eventually I'll print a nice version in something better. With an initial version printed out, I soldered a bunch of wires together, and honestly, I don't think my mental schematic worked very well. Well, actually it totally worked, but unfortunately the Xiao ESP32 doesn't have enough hardware timers to manage 8 different motors on each pin. I discovered this the hard way after multiple motors just wouldn't move no matter what I did, even if they were receiving voltage. Now, to work around this issue, usually servo-based projects use something like a PCA servo driver board. And while I would totally love using one of those, it definitely does not fit in our tiny little robot frame. Basically, I needed to figure out a way to allocate the PWM processing to something other than the main chip. And that's when I remembered the initial prototypes of my bigger robot Sesame used a Adafruit Metro Mini Arduino board. And so I dug through my pile and found this board, and it turned out to actually fit, which was great. There was one issue though. This board didn't have Wi-Fi or Bluetooth capabilities. And wireless connection was one of the criteria for building this robot. So I was gonna have to get creative and come up with a solution. Even though the Xiao ESP32 wasn't going to work as the main driver board, I figured maybe I could run both boards at the same time and then just have the Xiao as an ESP32 Wi-Fi bridge to the Arduino. I'll be honest, this is totally a band-aid solution, but I wired it up and wrote some really convoluted firmware. I'm going to explain how this firmware works, but I'm going to explain it like you're in a French bakery. Okay, bear with me. It's going to work, I swear. Alright, imagine you're walking into this bakery, it's very French, and this bakery is run by a robot. The fact that it's French is super important, by the way, keep that in mind. Alright, so there's two bakers. One baker, he is the artiste. He knows how to make the croissants. He knows how to do the little wave with he knows how to do the little wave when his hand when he says bonjour. He knows how to do the dance. You know what I'm talking about. He is the main board, the Metro Mini V2. That's him. The other baker, he just stands by the door and he's got a walkie-talkie in his hand connected to your phone. He doesn't bake anything. He just goes, oh, the customer wants a croissant. He says the customer wants a croissant, and he passes that note along to the main baker. That's the Wi-Fi bridge. That's the Xiao ESP32. Now you're outside of the bakery, and you pull up your phone, and the phone goes, the bakery is open. That is the captive portal. It's like the chalkboard sign on the door, and when you tap forward or stand in the web menu, the walkie-talkie baker guy goes, forward. and the artiste baker, he heard that and he's already moving. He's ready to go. Yeah, and then you get your baguettes, and that's how the firmware works. Alright, so anyway, that firmware did actually end up working, but it was around this point that I started shipping out pre-orders for the Sesame Robot build kit. I mentioned the Sesame Robot Project at the start of the video, but what I didn't mention is at the same time I was working on this project, I was releasing pre-orders for a build kit to build your own Sesame Robot. And if I have any advice at all, don't try to do an entire build kit of your robot and then release it as a commercial product in like 2 weeks. I mean, we got it done, but that was like an enormous amount of work. Okay, anyway, shout out to all my family who basically turned our house into a production line to get all of this out there. If you're interested, I am opening regular orders soon, and there's a waitlist you can join in the description of this video. Now, regardless, this insane endeavor meant that there was a little bit of a break on this micro robot project, but I was still simmering on ideas in the background. I was plotting, I had things up my sleeves. And so when I revisited the project finally, I printed it all out in much nicer filament, edited the design so that the top cover would actually fit onto the robot with all of the crazy wiring inside. And speaking of wiring, I literally snipped all of the servo connectors and then hand soldered them just so it would fit inside of the tiny frame. And now all the pieces of the puzzle were finally fitting together. I had the weird French firmware working and all of the motors and the hardware installed, and the robot was complete. So while this robot is based on the Sesame Robot Project, it's got quite a few differences, and it's actually quite difficult to build your own. I will, of course, be publishing the files on GitHub, fully open source for anyone to change or modify, but I likely won't be maintaining this repository nearly as much as the Sesame Robot Project. Also, yes, technically I didn't go and get a world record certificate or anything, but this is one of the smallest quadruped robots ever built. And honestly, that's kind of incredible because a lot of the parts in this robot are just hobbyist parts. You can buy them online. It's so exciting to me that we live in a time where you can Amazon order enough components to build your own micro pocket robot. It's freaking awesome. So yeah, if you like this video, subscribe. I don't really ask that very often, but I have some really cool videos upcoming and I think you would like them if you liked this one. I will end the video off by showcasing some of the incredible work of the Sesame Community Discord and their incredible modded Sesame builds.
Say hi, Sesame.
Thanks for watching, goodbye!